start up my Stellarium from scratch. I love the way Stellarium, if you mess something up, you just shut it down and restart it, and then everything's back the way you like it.
I love things with a high tolerance for mistakes like that.
Yeah.
Okay, so we're up on YouTube now, and hello from everyone joining from all over the place. I love seeing where you guys are from. So tell us in the chat where you're joining from. We're gonna get started ASAP because I apparently take too long to talk to people who are joining. So we're gonna start with, today is a tour of the Southern Hemisphere. So Chris is gonna be taking us around the Southern Hemisphere skies. But I did want to, first of all, ask you guys a question for those of you who are on Zoom. I'm going to ask you whether or not you've been to the Southern Hemisphere before, and if you have been there, whether or not you saw the stars, because I certainly have. I think I've been to the Southern Hemisphere, but it wasn't at a time when I was interested in astronomy, so I didn't get to see anything that was interesting, or at least I didn't know.
I spent nearly a month in the deserts of Sudan, 20 years ago, without a binoculars, without a telescope. And I was a geophysicist then. I wasn't thinking up, I was thinking down.
Oh no.
I just kicked myself now.
If only you'd known, if only past you had been aware. A month, that would have been amazing. Oh. Okay, I'm gonna end the poll because it looks like most folks have voted. And so we've got most people not having been to the Southern Hemisphere before, and most definitely not have been observing down there. There we go, there are the results.
Oh.
Abu Simbel, okay, I was gonna say that's not in the south. I've been to Abu Simbel too. So I was confused for a sec. Yeah, so we got a good number of people. A lot of folks, I love hearing about astronomers who go down just to see space in the Southern Hemisphere.
Yeah, well, so what I'm gonna do this afternoon is I'm going to try to give people a sense of how it compares to what we're used to and what to look for when you go there, and just sort of show how the world's different. I mean, it's down under and things are upside down. So that has a bunch of ramifications that are really cool to think about. And, we'll talk about some other cool aspects. So let's sort of dive in a little bit. I'm just going to start sharing my screen here. So give me a second here. And I'm going to share some cool videos. So we have a Toronto Centre member who's actually on the National Council. His name's Mike Watson. And he is a gifted astrophotographer. And one of his favorite things to do is to travel to Australia with his telescopes and cameras and just collect photons and all kinds of glorious pictures. So he gave me permission to dip into his Flickr album collection, and I'm going to show you some highlights from his photographs that might also help to inspire you to look further in that, and also to do your own photography if you ever get to go down there.
Oftentimes, if anyone's curious, if I'm ever showing photos as like visual support for a presentation, they're almost always Michael Watson's because he just takes so many and they're so easy to find.
Yeah, that's one great thing about it, is he makes them so readily accessible to people. I really appreciate that about him. But and of course, it's nice. You always want to make sure you ask permission if rascals share their photos. Try to get their permission before you go on and share them beyond to some other people. It's good to get their permission. All right, so just to set the stage, so we live here in Canada. We're used to the Canadian sky, and the way we typically work is we've got the planets, and the sun and the moon tend to be in the southern half of the sky, right? Because we live in the north, and the plane of the solar system is kind of south of us. So we won't want to see the planets and the moon and the sun. They're always in the southerly sky, or the southern half of the sky. And for us, well, for everyone on Earth, the objects rise in the east and then they set in the west. Now for us in Canada, that we grow up thinking that's stuff rises on the left if we're facing south, and it sets on the right if we're facing south, right? So the things move kind of left to right across the sky. And that's not the same when you go on to the Southern Hemisphere. So we're going to talk about that a little bit. Now we have, overall in the sky, there are 88 official constellations, and each constellation has a territory, and these are the boundaries, and there's no overlap. So every object in the sky has an address in one of the constellations. And of the 88, we don't see all of them from Canada. There's about 20 or so that we can't see, that we never see, because they're in the southern hemisphere. Now, if you imagine the plane of the solar system, you know, the sun's in the Milky Way and we're sitting here going around the sun. If the Earth's axis was directly perpendicular to the ecliptic, then everybody in the northern half of the Earth would never see the bottom half of the stars, the southern sky, and vice versa. But because the Earth has a tip of its axis, we dip down and see a sampling of the southern portion of the sky. So because of that 23.5-degree tilt of our axis, we do sample more than 50% of the sky. So we get about 3/4 of the constellations from here in Canada. And so you're going to hear names that you've never heard of before, maybe in the southern sky, things that just never peak above the horizon for us. All right, so let me turn and face us north now, because we also have phenomena that are associated with that. So here we are facing north, and we've got our friend Polaris sitting here in the northern sky. And Polaris is close to the North Celestial Pole. That's the point in the sky that the Earth's axis aims at. And I can draw an equatorial grid on here, so you can see that. And if I advance the time, then of course, as the Earth rotates, the North Celestial Pole stays in the same spot because a rotating orb, its axis points to the same spot and everything else looks elsewhere. So as the Earth rotates, the stars go around the North Celestial Pole. Now, Polaris isn't right on the North Celestial Pole. It's about 40 arc minutes off of it. So let me just bring it up, a little magnification here. So there's the actual North Celestial Pole, and Polaris revolves around it. It's about your index finger's width apart from it. And of course, Polaris is there in the day and night, 365, 24 hours a day, 7 days a week, 365 days of the year. It's always in this patch of the sky, even in the daytime for us. Now, let me just pause time here. I'm just going to set this back to now, and I'm just going to set it back to tonight. Let's let the sun go down and the stars come in. So here we have the sky in the evening, about 10:30 p.m. or something like that. So Polaris's height above the horizon is equal to your latitude on the Earth. And that means that if you go elsewhere on the planet, if you're moving north and south, then Polaris's positions in the sky is going to change for you. So we could actually bring up the location controls in Stellarium. And if you put your cursor on the latitude and on the degree, just put the cursor somewhere on the 43 there and go over to the up and down arrow, and you can fly yourself north as if you're in a plane or if you had a road that's continuously north. So if you drive north, Polaris goes up. And obviously if you head south, Polaris goes down. So if you get to the North Pole, Polaris would be straight over your head. If you get down to the equator, here we are, 9, 8, 5, 4, 3, 2, 1. I'll just put 0, 0 here just so we have basically 0 degrees. So if you live on the equator, then Polaris would just hug the horizon all the time. And as the Earth goes around, then we just see this, whatever half happens to be, whatever half of the stars happen to be above the sky. All right, let's go back to Toronto for a second here. All right. So that's being able to use, Stellarium to move around the sky.
I have just a general question, Chris. Can I ask you now?
Yeah.
If you were living at the equator, so then theoretically you'd be able to see all the constellations at some point in the year or another.
Yeah, exactly.
Oh,
so
nice.
Let's actually do that. So if we swoop around and look south now, and let me just clean up some of the clutter on here. So I'll get rid of the grid and I get rid of
Are we back? We're back home now, eh?
Yeah, so we are back home in Toronto. Toronto, Canada. The idea is that if you drove east and west, you wouldn't be affecting how high Polaris is that much, right? If you stay at the same latitude, all you're doing is delaying or advancing when you see the same stuff. So if Jupiter is 20 degrees above the horizon at a given time of the night, then at some point everybody in the world at that local time, at that latitude, are going to see Jupiter in the same spot. For them, it doesn't matter.
Right. So,
But
for
the
example,
point-
that's why you could see the same constellations in France as you would in Ontario.
Exactly. Yeah. Exactly. So, well, you know, when you talk about the Messier list, Charles Messier listed those 110 objects. I mean, he didn't pick 110, but we developed it into 110 from France. And because Canada is comparable to France in latitude, we can see the same set of Messier objects at the right time of the year. All right, so let's see what else we can. So what else we're going to do is we've also got, we talked about this a couple weeks ago, that we've got the center of our Milky Way galaxy is sort of hugging the southern horizon in the summertime for people in Canada. And if we do that drive south thing, then that's going to rise up too. Now, just one more thing I want to bring up is I want to bring up the markings and show you circumpolar. So let's do the circumpolar circles. And let's put on the celestial equator. All right, so let's do that for a second. So just looking north again for a second, I've drawn this big yellow circle in the sky, and for our latitude in Toronto, these constellations inside that big circle, they never drop below the horizon for us. They're what you call circumpolar constellations. All the rest of them can be hidden by the horizon of the Earth. And as we drive south, then that circle shrinks because Polaris is dropping towards the horizon. And if we drive north, then that circle gets bigger because more constellations are always visible for us. Let's just go back to Toronto. Likewise, I've got this other line here. This is the equator. So if we took the Earth's equator and we painted it across the sky, if you lived at the equator, it would be over your head all the time, right? For us, it's in the southern half of the sky because we're looking kind of down on the plane of the solar system. And so we divide the sky into two bowls, a northern bowl and a southern bowl. And all the constellations that we're familiar with in Canada tend to be in the upper bowl. And the ones that we never get a glimpse of are part of the southern bowl of the sky. So that's why we're gonna fly to the southern hemisphere. Now, if you go south, you can think about, you know, who lives where. So at about, we're about at 43 degrees, you know, the 40s, in the 40s latitude for Canada, most of the populated parts of Canada. If you think of the southern hemisphere, it's a little more sparse. So if you go to about 30 degrees south, not as far south as we are north. At about 30 degrees south, that's where Cape Town is in South Africa. That's getting close to where Sydney, Australia is. And it's parts of Argentina, you know, the skinny part of South America is down there. Going down to 35 south, you get more into a band across Australia. You're picking up parts of New Zealand now because New Zealand is actually further south than Australia is. And you're getting parts of Chile and Argentina again. And then about 40, you're picking up the North Island of New Zealand. You get Tasmania, which is just below Australia. And then you're getting Chile and Argentina again because they sort of point down towards Antarctica. And if you go as far south as we are north, so about 43 degrees south, that's when you're getting to the very tip of South America and you're getting New Zealand South Island. And after that, it's Antarctica and hardly anybody lives there. Although, you know, 6 months of the year, they have these perfect black skies. All right. So if you're going to take a trip to the Southern Hemisphere to enjoy the stars, then your choices are, you know, Africa, South America, or Australia, New Zealand. Those are the most popular ones. And of course, Australia and New Zealand tend to be the you know, easiest, more populated ones and more built up and more destinations for tourists and things like that. So that's,
there's a question in the Q&A from Galen asking about affordable and relatively safe South American destinations. I've personally never been that far south in South America. But I found, and when it comes to affordable, we went to Peru, not terribly safe, but it was really fun. I would guess Argentina would be pretty safe, huh?
Chile is popular because Chile has a lot of astronomy there. There are a lot of observatories based in Chile, so it's sort of astronomy friendly. So if you're doing an astronomy tourism thing, that one sort of pops up a lot. Because then
Okay.
you can tour the observatories down there. There's radio telescopes and there's also optical observatories near Chile. So I have friends that have been there many times. But
Okay. Yeah, astronomers need things for the daytime too.
yeah, and that's why, you know, Australia is great. New Zealand is fantastic. You've got your glorious landscape in the daytime, and then you've got your stars at night if you're away from the big cities. All right, so let's head south. So what I'm actually going to do is I'm going to drive us south, and you can watch the southern sky raise up. Now this Z that I've got marked on my stellarium, that's the zenith, right? That's straight overhead. So as we head south, things are heading towards the zenith. And by the time we get down to the equator, you can see that, oops, let me just change this around a little bit. See that the planets are getting really high. So if you really want to get good views of the planets, you want to go south where they get higher in the sky. And that's when we're looking at them through the least amount of Earth's disturbing atmosphere. The other thing is that the center of the galaxy gets much, much higher in the sky. So when we're seeing it in the summer from southern Canada and it's hugging the horizon, we're getting a good view, but we're getting a lot of ground fog and we're getting a lot of thick atmosphere to look it through. So if you really want to get some amazing views of the southern sky, and I'll pull up some of Mike Watson's pictures in a bit here, you can plan to go south. And you know, you can go down to Arizona or Florida, someplace in the southern states or Mexico, and you're getting close. But if you really want to see the rest of the world's sky, you've got to go well below the equator. So let's keep going south.
I've heard of course, Hawaii has a bunch of telescopes as well. So another good location to go and see the Milky Way.
Yeah, Hawaii is not that south. I think it's well north of the equator. I'd have to look it up, but my impression is that it's there. So as you can see, I'm here at minus 35 degrees south now. And here's that yellow circle, the circumpolar, but this circle is drawn around the southern celestial pole. So we had the Earth's north celestial pole with Polaris above, but the corresponding southern one is the south celestial pole. And guess what? There is no Polaris for them. So they have no star. So in the north, we use Polaris to help us align our telescopes to accurately track the stars, just by counteracting the effect of the Earth's rotation. But in the southern hemisphere, they don't have a Polaris to use for that. So they have other tricks, then we'll talk about that. So there
was a question about it in the chat, and Michael Watson has already responded with how difficult it was. And Michael, just a heads up, if you want to talk to everyone, you will have to change it to all panelists and attendees. So I'll copy his answer over so you can see it, but perhaps we can get to that afterwards.
Absolutely. All right, so I'm gonna take off the ecliptic just to keep things a little bit cleaner, and I'll take off the equator here just to keep the sky a little bit cleaner as well. Yeah, so there's that circumpolar circle. So everything, we're now sitting in Sydney, Australia. So we're seeing the Australian sky. And this is the sky tonight from there. And everything inside the yellow circle would be things that never set for them, for people that are stargazing from there. And already you can see some weird things going on here. Look at this. Here's Phoenix, the constellation Phoenix. Grus is the crane. We have Pavo. Pavo's a peacock. So most of the constellations that we're used to dealing with are the ones that were observed from by the Middle Eastern astronomers, the Greeks and the Romans, who kind of assigned those constellations. And they of course used, and that's Western astronomy, if you like, not indigenous astronomy and that kind of thing. And we'll talk about the Maoris and that kind of and some of those in a little while. But the southern sky was relatively unknown, so the constellations for Western astronomers weren't identified or created. So the constellations didn't really get generated until the people started to go on seafaring voyages to the southern skies. And so what happened is that a lot of the constellations got named after sort of technological things like the quadrant, there's
a telescope,
the compass that's used to draw a circle, the telescope. Yeah. So I'll go through the list in a little bit. So you'll see, yeah, there's a lot of different names. Now, I want to just hop back here and go back to the planets for a second. I want to get the moon in the sky. So let's just get the moon back. So there's the moon. So here's what's funny. So Hollywood makes movies all the time and shows the moon in the sky. But the people who live or who grew up in the Southern Hemisphere, they all think it's wrong, because if you live in the Southern Hemisphere, the moon is flipped over and it's the other way around. And what I can do is I can artificially flip the moon back. So here's the moon back. So here's our Wilma Flintstone. She's actually facing the wrong way. Where is her
Yeah.
face? Yeah, it's flipped around.
Oh, there's her. Yeah, it's backwards. Yeah.
Yeah.
Ah.
Well, so they grew up seeing the moon like this. And then if they see the moon in a movie, then to them it looks wrong. And the pictures that that I heard, one of the stories that I heard from the indigenous storytellers in the Southern Hemisphere is that the image that they see in the moon is that of a woman. So here's the woman, here's her head, and here's her sort of her body and her legs. And she's actually carrying a water gourd.
Huh.
And the story is that she went off to get water at night, and the moon was shining in the sky, and the moon was hidden behind a cloud or a tree or something, and it caused the ground to go dark at her feet. And so she tripped and spilled the water. And she actually said a bit of, said something unflattering about the moon at that point. And the moon spirit took offense to that and decided to grab her and pull her up into the sky. And so he grabbed her by the ankle and he started pulling her up in the sky. That's why she's hanging upside down here. Let me just see if I can get her the right way up. So you can see she's hanging upside down. And what she did is that she reached down and she grabbed a hold of a tree. There's actually the shape of a tree. It's a little bit hard to tell in this particular picture, but you can find some online. And so their sort of version of Man in the Moon is the woman in the moon being pulled up into the sky and holding onto the tree. And so that's a different perspective on the moon. So that's something you're going to have to get used to. The other thing you have to get used to, and we'll just go back to a full sky view here, is that near a full moon, the moon rises at sunset, but it rises from the right, not from the left. So everything's flipped around. So during the course of the night, the planets and the moon and the sun during the day, they all travel looking north from the east, which is on your right, and they set on your left. So it takes some time to figure that out. The other thing that happens is that, just to finish up this thought about the moon, is that if we go back a couple of weeks, as the moon waxes fuller, let's just go back here a little bit. It's actually filling with light from the left instead of filling with light from the right. So when you see the moon not quite fully lit, not quite fully illuminated on the right, that means it's waxing, where in our case, we're used to this being waning. So it's a different phenomenon. So anyway, that's just something you can sort of keep in mind if you ever plan to head down.
You think you have a handle on orbital mechanics, and then you're sent to the Southern Hemisphere.
All right. So that's going to on your face. And the other thing is, as I kind of alluded to, let me go back to set this all back up. Everything's all set up. Yeah. So the other thing is that the good stuff is now facing north instead of facing south. All right.
That was where, because like technically speaking, it still rises, things still rise in the east and set in the west. It's just that instead of facing south to look at all the good stuff, you're facing north to look at all the good stuff.
Yeah. All right. So now the other neat thing is we've got the Milky Way here. Let me just take off the constellations for a second here. And again, this is the teapot shape of Sagittarius, and the center of our Milky Way galaxy is sitting just outside of the spout of the teapot, which is upside down in this case, but it's basically somewhere around there. And you can see that it's almost to the zenith. And so if you ever want to feel like you live inside a galaxy, you want to go to the southern hemisphere and wait till the time when the center of the galaxy is overhead, and the disk of the galaxy will stretch to the left and to the right, horizon to horizon. And you get the entire span of the galaxy from horizon to horizon if you get out into the country where the sky is black. So it really gives you that neat cosmic sense of living in a galaxy. All right, so let's swing around and face south, and let's just have some fun looking at some of these unfamiliar constellations that we're not used to. Let me just pause this and set this up to about, so this is about 10 p.m. on August 11th. So the first thing you're going to notice are the super bright stars that that are blessed to have in the southern hemisphere. And one of those is this patch of sky here, which includes the Southern Cross. And the Southern Cross is of course, used in the
Hey.
Australia, New Zealand, some of the South Pacific countries feature the Southern Cross stars in their flags. And we also have these two bright stars, Rigel Kentaurus and Hadar, and they just knock your socks off. They're so bright, so amazing from the southern sky. So Crux would be the equivalent of the Big Dipper for people in the southern hemisphere. It would be the sort of the big famous constellation that nobody has any problem recognizing. All right, so let's look at what we've got here in the way of constellations. As I sort of mentioned a few of them already. So we've got Crux, and Crux consists of these four really bright stars. There's Alpha, the Alpha star is a Crux. So it's actually a double star. In a telescope, it splits into a little double star. Then we've got Beta Crux you can use the name B Crux or the name Mimosa. Different Stellarium uses some variety of names for some stars. Then we have Ga Crux or Gay Crux. That's Gamma, Gamma Crucis would be the Latin name for it. And then you have Imai, which is Delta. So Alpha, Beta, Gamma, Delta, A, B, C, D for the stars in the corner. And of course, the constellation includes some things around it. And you might notice that the Milky Way here is not uniformly bright. There are brighter patches and darker patches. And this sort of darker part of the Milky Way is we call the coal sack. Its nickname is the coal sack, because in the sky, it looks like a dark, somebody forgot to put stars there. And really what it is that it's dust that's obscuring the light from the stars beyond it. And so it makes a dark patch in the sky. So there's your Southern Cross. And then just above the Southern Cross here, this particular time of the night and time of the year, is we've got these two bright stars. Sometimes these are called the pointers that point to Crux. This is Rigel Kentaurus. And Rigel Kentaurus is better known as Alpha Centauri. And this is the star we talked about in the science fiction episode that people are going to because it's so darn close. It's only, where is it here? 4.39 light years from the sun. So if there was a civilization orbiting Alpha Centauri, the round trip message time rate in using light, the speed of light, would be 9 years or so, less than 9 years. Now, Rigel Kentaurus is actually the third brightest star in the sky, not counting the sun. So number one is Sirius, which we see in Canada. Number two is Canopus, which we'll come back to in a bit here. And number three is Rigel Kentaurus or Alpha Centauri. And it's actually a triple star system. I think we talked about this a couple of sessions ago or a few sessions ago. And it has in a telescope, let me just see if I can zoom in on it here. It splits into two. But there's a third star in the group that's a red dwarf. It's dim, it's magnitude, I forget, might be very dim, like not even visible in a regular backyard telescope. But its nickname is Proxima, and it's the closest star to the sun. So it's 4.3 something, I forget, but it's the absolute closest one. So that's and then Hatter is Beta Centauri, so Alpha and Beta Centauri. All right. So what else we got? So now we've also got, here's a few other things we could talk about. Where's Carina? So Carina, now I can see up here we've got Scorpius. So in Canada, we're used to seeing the top of Scorpius, but the bottom of Scorpius either hugs the horizon or maybe gets a little bit cut off. But of course, in the Southern Hemisphere, it sits right overhead, which is great because the Milky Way goes right through it and there's some glorious eye candy in that part of the sky. All right, so we also have, let's see, I might have to change the time here to get us a few other parts. So let's just advance the time here. Okay. So by about 1 a.m., we get this constellation Carina coming up, and there's Canopus. So that's after Sirius. Canopus is the second brightest star in the sky, and we can see it from Canada at times, certain times of the year. It just sneaks above the horizon, depending on your latitude in the country. Now, Carina is actually part of a constellation that got broken up. So you remember the legend of Jason and the Argonauts? So the Argonauts were sailors on the ship, the Argo.
Right.
And Carina is the keel of the ship Argo. And the constellation of, let me see the rest of it here. Puppis, which we get the top of in Canada. So Puppis is the ship's stern. You know, the part where behind the wheel where the captain would stand overlooking all the sailors, that's the stern. That's Puppis. And then Vela is the sail. So all of these stars put together were the ship Argo, the old constellation of Argo.
Can I throw something out quickly? So the Rask national offices have an archives room with all these old books that our archivist Randall Rosenfeld finds for us. And I went looking through those books for constellations when I was doing a presentation once, and I found the Argo constellation, and I was like, this thing is giant. And it is super cool how these constellations change over time, and how, you know, we think that they're this way forever and that's the only way, but they do change a little bit here and there. And so on that note, of course, the Rask archives are closed right now because of COVID, but when they open up again, our office is in Toronto. If you're nearby, you can drop by and check it out. And we can see if we can find those old books if you're interested in seeing older versions of the constellations.
Yeah, that's why the Quadrantids meteor shower that we get in Canada, it's from a constellation that doesn't exist anymore, called the Mural Quadrant. It's up near Draco and Hercules, and in that gap between those constellations. Yeah. So things get rearranged and redone. Okay, let's talk about the creatures that we have. So I'm just going to bring up some of the artwork here so we can see the various creatures we've got. So we've got Pavo the peacock. We've got Tucana the toucan. Where's Tucana? I may have the wrong time of the night. So
Tucana's up there. It's just up above between. No, wait, come back. Hydrus and Pavo in that circle between there.
Yeah. All right. Yeah. And then we've got Musca. Musca was a fun one. So when I went to Australia in the spring of 2017, we were looking at Musca because Musca sits right below Crux. And there's a cool object that's near Musca. So Musca is the housefly. Who knows why it merited a constellation, but it did. We have the chameleon. Where's the chameleon? He's up here somewhere. There's chameleon right in the middle. We've got volans, the flying fish. Here's volans. Volan sort of looks like kind of like an infinity symbol on it, that sort of a shape. We have Grus, as I mentioned. Grus is the crane. Grus you can see from Florida. It's far enough away from the South Celestial Pole. We have Apus. Apus is the bird of paradise. We have Columba, the dove. Where's Columba? Forgive me, I don't have all these memorized because I'm not.
I don't see Columba.
Anyway, it's there. Maybe the different time of the night. Let's see. I can bring it up. I'm sure there's Columba over here. We have Dorado, the fish. Here's Dorado, the swordfish. And we have Phoenix. Where's Phoenix? The Firebird. There's Phoenix, as I mentioned before. And then in terms of the sort of devices, the sort of technological things that are constellation, we have Atlia, the pump. So where's Atlia, the pump? And again, people are shouting at home, there it is, and I'm not seeing it. We have Calum, the chisel. We have Circinus, the compass. You know, if you want to draw a circle, you use the 2 points and you draw a circle. That kind of compass. We have Fornax, the furnace. Fornax we get little bits of in southern Canada because it's sort of far enough away from the horizon. We have Horologium, the clock. We have Mensa, the table. Mensa is like Canis Minoris, where it's just a stick, but it's meant to be the top of the table. We have Microscopium, the microscope. We have Norma. Norma is the carpenter square. I'm not sure where Norma is right now. There's Norma there, carpenter square. And we have Octans, the octant. And we have Pictor, the easel. It's around here somewhere. And we have Pyxis, which is the ship's compass. And Reticulum, which is a net or a reticle. And Telescopium, as you mentioned a little while ago, over here. And again, it's just a stick.
Just a stick, yeah.
And Triangulum, the southern triangles. We have a northern triangle and we have a southern triangle. So that sort of gives you some names that you've never heard of, and you think, oh, now you know where they are and why you haven't heard of them. You hear of some of these constellations. So the rule of thumb here is if the constellations are sufficiently far from the yellow circle, outside the yellow circle, we get glimpses of them in Canada. So we do see parts of Puppis, maybe a hint of Columbia if we're down maybe towards Point Pelee, the southern tip of Lake Erie there. We get Eridanus, we get glimpses of Fornax, we get Sculptor, there's some galaxies in there, Pisces or Austrinus, the head of Grus. So things like that we can get a view of. So let's talk a little bit about this this no Polaris problem. So if I bring up the grid for the southern celestial pole, you can see this is where you'd want to aim your telescope mount, but there's really nothing there to easily point at unless you can get your binoculars out and you can look for this little triangle or something like that and kind of eyeball it that way. There's a way of doing it that way. The couple of stars here, the delta octans and beta octans, those are naked eye stars. So they're useful to get yourself in the neighborhood. But yeah, so if you've got an equatorial mount with a polar scope on it, you might have a reticle on the polar scope that shows you the Big Dipper and Cassiopeia to show you how to find Polaris. But you might also notice that the octans stars are on there. And so you can use that same mount in the southern hemisphere using octans as your guide to a line. All right, so let's put these away and just clean that up. So let's talk about what we can see in the southern hemisphere. So first thing that's gonna blow your mind or catch your eye when you get down to the southern hemisphere, and the Stellarium isn't doing a great job of showing you, but of course I mentioned the Milky Way and how you want to see that, especially in the springtime. I want to show you something that's really cool in the Milky Way. So I'm going to go down to, I'm going to set the date back to springtime, and I'm going to go around midnight here, and I'm going to turn off everything and just show you, turn off that and that, and turn off the stars. And I'm going to turn off the planets. And when you go to the southern hemisphere and you get a night where the Milky Way is crossing the sky, you can look at the dark dust lanes that are blocking the light from the Milky Way galaxy. And if you might notice that up here, there's a dark patch. So now I'm going to trace this out for you. This is actually a head. This is a beak. This is a long neck. And this is a back, and this is a stomach, and then down here are legs, and it's a giant emu. And so the indigenous people of Australia and New Zealand see this giant shape in the Milky Way, and that's become their creation myth. They believe that the great emu sort of set up the lands and set up, you know, nature for humans to live on. So that's kind of their creation myth, the great emu. So that it's not great showing really well in Stellarium, but if you watch shows like Survivor, and they'll often do a time lapse when they come back from commercials, and they'll show the Milky Way going across, and because they're based in the South Sea Islands, you can get the emu and things like that coming into view.
Are you going to show some of Michael Watson's photos of the center of the Milky Way? Because he's got some really good ones too.
Yeah, let's do that. So let me just pull up a couple here. Let's bring up this one here first. Actually, I'm gonna do it this way. I'll just dedicate. So it's a little bit, you know, when you're not used to the orientation of things, it's a little bit hard to find where things are. But basically, I think this pink patch is around, I guess this would be kind of Lagoon Nebula, Eagle Nebula, sort of Sagittarius, center of the Milky Way. And then this would be the heading up into Cygnus. If Mike wants to chime in, he certainly can. But I encourage you to dive in. Oh, here we go.
Oh, there we go. Thank you, Michael, for including these. They're fantastic.
Yeah. Eagle Nebula, Omega Nebula, Messier 25. Here's Scutum. So this would be Aquila in this region, and then we get into Cygnus down here, and we'd get up to, that's probably Vega. Yeah, there's Altair. Doesn't go quite as far to pick up Cygnus, but this is just sort of a zoomed in patch. And you can really see how the dust, you know, obscures the stars.
So as long exposure, when you take, so of course, when you look at the Milky Way, it doesn't always look like this. And that's because photos of the Milky Way are taken for a long period of time. And so that gives you, our eyes are really good at seeing either detail or darkness, not both. And so in the dark, it's really hard to see all those little details, but with the photos, you can really see where the like the dust is and where the little nebulas are and that sort of stuff. Yeah,
exactly. And the pink color you're seeing there is hydrogen gas that's glowing from the radiation of the star, the hot stars within them that are energizing the hydrogen gas and causing it to glow with that nice pink color, that sort of ionized hydrogen color. And so when you look at, say, Hubble Space Telescope pictures of other galaxies, you can find those knots of pink where their stars are being formed in those galaxies. All right, so let's pull this off for a second here. And I'll come back to some of those in a couple minutes. All right. So the other thing that you're going to see is, let's see if I can pick these up. Go back to August here. I don't know if you can see there's a little smudge. Can you see there's a smudge down here and a smudge up here?
Yeah, we can see them.
Yeah, so those are the Magellanic Clouds, named after Magellan, who explored the Southern Hemisphere. And these are dwarf irregular galaxies that are gravitationally bound to our Milky Way. So our Milky Way's disk is about 100,000 plus light years in diameter. And these two galaxies, so the one is large, you can see this a bit bigger, and one is small. And to the naked eye, they look like little clouds that don't move. So they look like clouds in the sky. They're bright enough to see with your unaided eyes, just standing out on a dark sky.
Oh, man.
So the, let's see, the small one is about the width of your palm at arm's length. And the large one would be about your fist diameter in the sky. So they're really, really big. They're really extensive. One of them, the smaller one is 163,000 light years away. So 1.5 times the width of the galaxy, of our galaxy. And the other one is 206,000 light years away. So you can think of these as sort of spare galaxies spare galaxies that we have in our back pocket that you can only see in the southern hemisphere. So I don't have my circumpolar ring up, but they're inside the circumpolar ring. So they're up all the time, but we never get to see them from Canada. So they're one of the top reasons to go to the southern hemisphere. One of the first things you'll notice. Let's see. Yeah. So I think, yeah. The other neat thing is that they're loaded with deep sky objects. So if you zoom in, and we'll zoom in on Mike, we'll go to Mike Watson's here next. Let's see if I can find a good one of Mike Watson. Okay. Okay, here's one. So here's a photo of both of them taken by Michael Watson. And again, if you go to his Flickr page, you can click on the image and it'll embiggen so you can see it full size.
Just to let you guys know, if you haven't seen in the chat already, Michael actually just linked that exact photo in the chat. So you have the link there if you'd like to see it.
He's intimately familiar with all those great pictures, and whereas I've got 200 in this folder, and I'm trying to sort of decide what to show. But there you go. And what you can notice is that you see that pink knot. So even this little dwarf irregular galaxy, it has its own star forming region, just like we saw the ones in our Milky Way. And in fact, this one is actually called the Tarantula Nebula. And it's a bright patch in the sky. You don't get the color to the unaided eye without a long exposure, but it's there. I'll just see if I can bring up one of his detailed pictures of it. Okay, so there's a detailed picture of the small Magellanic Cloud. And again, you can see all the little knots of pink where stars are being formed inside it. And we'll just advance. So he's annotated a number of them. So if you're familiar with the new general catalog, the NGC list of objects, there's about 7,000 of them, so that kind of thing. A number of them are actually in another galaxy because they're the little knots and individual objects in some of these other galaxies. And then here is an enlargement of the Large Magellanic Cloud, and here's that nebula I was pointing out a few minutes ago. So that's called the Tarantula Nebula. Let's see if he's got a magnified version of that coming up here. Yeah. That's Eta Carina. I don't want that one. I'll come back to that one. We'll go back to the album and see if he's got the tarantula.
That's crazy. That's so cool to think that we can see deep sky objects that are in other galaxies. Most of the deep sky objects we know of are within our own galaxy, except for the odd galaxy that's out there.
Yeah. Now, again, that's a naked eye object. It's about this big as the full moon, that nebula. So of course it's even better in telescopes and binoculars, but you can just stand out in a dark, dark sky and look at it with your own unaided eyes. All right, so I'm going to go back and show you a couple of other things here.
One of the things that RASC members are known for is planning trips to various places to do astronomy. That's what they do, it seems. So you may be inspiring a next trip to the Southern Hemisphere in the eyes of many folks who are wishing they could travel right now and can't.
Well, I'm actually going to get to that a bit.
Okay.
Yeah. We're thinking alike. All right, so let's see what else we have. So what I've got here is, I'm just going to declutter this a little bit. So in Stellarium, you go to the Deep Sky Objects tab, you can actually change what classes of objects are displayed. Now we've covered the Messier objects in the past. So the Messier objects are the 110 objects in the Messier list that were first picked up as being not comets as visible from France back in the 1800s. And one of the cool things about traveling to the Southern Hemisphere is that the ones that are kind of too low to get a good view of in Canada can sit nice and high in the sky from the Southern Hemisphere. So if you've ever struggled to see some of the globular clusters in, in Sagittarius, or I've got a list of them that I made. Yeah, M54, M55, M68. There's a bunch of them that are sort of hug the horizon for us. And of course, you go into the southern hemisphere, they're nice and high, they can reach the zenith, and we can see them through the minimum amount of disturbing atmosphere and really, really enjoy them in a great way. So these are just the Messier objects. Now, we'll go back and let's pull up the NGC objects. And I'm just going to dial this back to pick up just the sort of biggest and brightest. Okay, so facing, we want to face north. Remember, I keep forgetting. So we want to face north. Yeah.
I always make, whenever I'm talking about Pegasus, I always make a joke about how he's upside down, and it's an upside down 2/3 of a horse kind of constellation, which is a silly constellation to have, I think. But here he's the right way up.
Yeah, and we're actually, that's a good one to remember. I'm actually going to talk about a little bit of that in a little while. All right, so I'm going to bring up my circumpolar, circumpolar circle here again. All right, so here we go. So the other thing that's going to catch your eye, and again, let me just bring up a few more of these here. Okay. So the next one that I'm going to talk about is, here we go, 47 Tucanae. So again, facing south, 47 Tucanae is a globular cluster. It might even be the stripped remaining core of a dwarf galaxy that had its arms and its outer gas taken away and just left the core. But it looks like a globular cluster, basically. And if you zoom in on it, it looks like this. And I'm just going to bring up Mike Watson, one of Mike Watson's pictures, because I think he's got a good one in here. Here we go. Here's 47 Tucanae.
Oh, wow.
So it's basically the brightest globular cluster type object in the entire night sky. So if you want to see your best globular cluster, that's your candidate right there. You have to go to the southern hemisphere. Much bigger and brighter than M13.
Wow.
Yeah. So this, you can see up here in the corner, I think M13 is magnitude 6 or 7 or something like that. This is magnitude 4, which is much brighter. So it's basically a dead easy naked eye object. You just like, what's that big glob? Oh, it's 47 Tuc. In the sky, it's almost the size of the full moon.
Whoa.
Yeah. It's 15,000 light years away. So that's much closer than M13 is. All right, so that's 47 Tuc. Let's see if he's got, yeah, he does. Let's bring up the next one. So let me just wind this back.
I'm feeling very jealous of everybody in the southern hemisphere who gets all these cool naked eye targets.
There we go. So the other one is over here. Let me see if I find it. There we go. Omega Centauri. So Omega Centauri is another similar object. And it's kind of like just out of sight in Canada.
Oh.
You know, we can't make it in Canada. We can see, you know, there's the bottom of Scorpius that we can see in Canada. And so it's just kind of skimming the horizon. I think I heard that people who went to Point Pelee Provincial Park could get a glimpse of it if the southern horizon was clear. Anyway, here's Mike Watson.
In the entire country.
Yeah, Omega Centauri.
Wow.
All right. So I talked about the coal sack. That was another one. This dark patch. Now the coal sack is the head of the emu. All right. So there's the emu, there's the emu's beak, and the rest of the emu is upside down in this particular view. So that's what the coal sack is. It's the head of the emu. All right. All right. back to my notes. All right, so let's just finish up with a few more fantastic sort of eye candy that you want to travel to the Southern Hemisphere to see. So when I was there, I was lucky enough to have access to telescopes and a dark sky sight. And I actually had a separate adventure where I went to an observatory in New Zealand, and it was too windy to observe, so that let me look through their 1 meter telescope for a few hours. And we just
Whoa.
looked at cool stuff.
That's spoiled. The 1 meter
Yeah.
telescope.
It was amazing. So let me just look for Eta Carina here, and I'll bring up Mike's picture in a second here. Okay, Eta Carina. So Eta Carina is another one of those nebulas, sort of like the tarantula, where it's a big patch of brightness in the sky, but it has an amazing erupting star in the center. The star Eta Carina, and I'll bring up Mike's picture here. I gave you a little hint of it a little while ago here. So where is he here? Eta Carina. Yeah. So here's a picture. Here's a better picture. And then here's an annotated version of it. And again, you can view these in full screen if you log into Mike's Flickr page, and I'll make sure that he's already shared the link, so you'll know where to get to them. Mm-hmm. So the Eta Carina star that's in the center of this is an erupting star, and it's actually erupting asymmetrically. So it actually looks like almost looks like two candle flames base to base, kind of an hourglass shape. And the night that it was windy and I was observing through the 1 meter telescope, we pointed it at this object. And because the sky was unsteady, it looked like the candles were flickering. So it looked like two candles flickering in space. It was bucket list once in a lifetime thing.
Wow.
All right, so that's the Eta Carina. And by the way, many of these objects are very well placed for viewing in the springtime in Australia. I mean, Canadian spring, so April. So that's the fall in Australia. Yeah.
Okay.
Yeah.
If you're thinking of planning trips, bear that in mind.
Yeah. So let me pick a couple more, and then we'll kind of wrap up. We're open to questions. So I'm going to talk about the jewel box. So the jewel box is up here right near Crux. And in a telescope, I don't know if you can see here, can you see that there's 3 little stars in a row? And in a telescope, they look like traffic lights, like yellow, green, red. It just blows your mind. It was one of the coolest things I ever saw. And I went back and looked at it again and again and again. So it's called the jewel box.
That's very cool. One of those things that a lot of people don't realize is how much color you can see in space.
Well, stars have colors, so you can see those colors in a not very big telescope.
Mm-hmm.
Okay, let's find. The Southern Pleiades. And again, I'm just going to actually.
The Southern Pleiades.
Yeah, so there's the Northern Pleiades, but then that's a large open cluster that spans, a fair bit of the sky. It's 1 degree 40 arc minutes. So that's it's about 3 times the diameter of the moon. And it's a different shape, but it kind of resembles that effect of the little bright knot of stars that are sort of naked eye visible in the sky. And it's fantastic at binoculars, of course.
While you're looking for more things, I wanted to mention something that Michael said in the Zoom chat for those of you who are joining on YouTube, because you wouldn't be able to get to see this. But he mentioned that since there are very few Messier objects within 25 degrees of the North Pole, you can actually see most of the Messier objects from the Southern Hemisphere, even though they were primarily observed from the Northern Hemisphere.
Yeah, that's a great point. So if you're doing your Messier hunt, that's a great time to get a bunch. I've mentioned in the past sessions about the Caldwell objects. So Patrick Moore, the British astronomer, a number of years ago remarked that Messier skipped a bunch of great things that should have been in his list that weren't. And so he said, I'm going to pick another 110 objects that should have been on a list to make a separate list. So that plus Messier makes 220. But the catch is that Patrick Moore included the Southern Hemisphere skies.
Aha.
So when I was in Australia and I had these telescopes, I started hunting all them down. And so now I've got, I think, 3 or so to go to get the whole set, because I've had the benefit of being in the Southern Hemisphere to catch the most southerly ones. Number 1 is at the North Celestial Pole, and number 110 is near the South Celestial Pole. He ordered them, ranked them that way. So those are the Caldwell objects. So this is the Wishing Well cluster, another fantastic eye candy. Let's talk about the area around Antares. So Antares is loaded with this amazing nebulosity. There are reflection nebulas and emission nebulas that give you the different colors. And for us, Antares remains relatively low, but if you travel to the Southern Hemisphere, you can get Antares when it's high in the sky, and you can get these glorious pictures. So Mike's got pictures. If we have time, I'll pull up some more of his pictures of that part of the sky. The other cool thing in Scorpius is when you come down Scorpius, for us, we kind of lose these bottom 3 stars. We can pick up the double star at the tail, but we miss this little section generally below the horizon. And there's an object here called the False Comet Nebula / cluster. And it starts out with sort of a group of stars right as part of the constellation. And then there's scattered bright stars that form this sort of span that looks amazing if you get a chance to see it, even naked eye or with binoculars. It's fantastic, called the False Comet Nebula. And again, you don't have to go to the Southern Hemisphere. You can just head south into the US or something, and you can easily pick this up. All right. Now, last couple things I want to talk about. I want to talk about looking at the sky upside down or from another point of view. So I'm going to turn off. Well, I can leave this marking on, but I'm going to do is I'm going to turn off a bunch of things here, and I'm going to turn off the star labels. I'm going to turn off the deep sky objects. And let's see. Let's take off the stars. Oh, I put them on. Okay. So let's see. Okay. I'm looking for something in particular. Let's go with this part of the sky. Let's go back a few months. Here we go. Okay. So when you go to the Southern Hemisphere, you're going to notice this thing. This funny shape. And it looks like a frying pan. It's got 3 flat stars and then a handle that swings up. And that's actually Orion upside down.
Huh.
So when they look at Orion, they see they call it the frying pan.
That's so funny.
As a nickname,
Huh.
just for seeing it upside down. You mentioned
Pegasus.
Pegasus being upside down, and I just want to talk about Scorpius for a second. So talk about different perspectives.
While you're finding that, I just wanted to mention, I haven't observed much in the Southern Hemisphere at all, but on the occasion I've gone to the Southern States and seen constellations, you get used to the stars that are above your own head. And then when you go somewhere else, it feels like, I don't know, to me, it feels like I was on a different planet. I was like, no, I should know everything that's up there, but it's not, I don't.
Yeah. It takes a couple weeks to figure it out and get yourself oriented. I mean, first of all, you have to recognize the ones you know and see them upside down, and then you start having to learn the ones that you've never seen before.
Yeah.
But you get there, and it makes sense after a while. I've mentioned this in a previous session, but Scorpius has its tail dipping into the Milky Way. The Maori people of New Zealand, they see that set of stars and they interpret that as a fish hook. That's Maui's fish hook. So if you've seen the movie Moana, her companion in the movie is the burly guy, that's Maui. And he's a demigod, and he sort of helped found New Zealand people. And his he carries a hook over his shoulder, and that Scorpius constellation is they consider Maui's fish hook. And they see this as this hook is dragging the Milky Way up from the horizon in the sky. One thing I want to show you in the star, this may crash my Stellarium that did before, but I'll try it and see if I can make this work, is how different people see the sky. And I'm going to bring it up like this. And so what I've done, I'll just go back a few months here. Can you see that this constellation spans almost the whole sky, horizon to horizon? And this is actually the waka, the war canoe, the Maori war canoe. And it actually is composed of many things that we're familiar with. So here's Maui's fishhook. This is Antares' tail. So Scorpius's tail. So Scorpius comes up like this. So this would be the prow of the canoe. And then we've got Alpha Centauri and Beta. So these are sort of the oars. And this is the Southern Cross. This is sort of like an oar, I think, as well. And then you've got, let me just get this so I can see it a bit here. This is Alpha Carina. That's Canopus, the bright star Canopus that I mentioned earlier as being the second brightest star after Sirius. So it acts as the navigator, I believe. And then we've got Sirius. Sirius is a member of the crew in the war canoe. And then if I can get the very bottom here, let's see if I can get the bottom to come up. Then we have the stern of the canoe. So we've got Sirius down there. And I think if I can get this to come up, this should be Taurus. So Antares is sort of the anchor, or the anchor that they throw down. So they, of course, every culture interprets the stars in the sky differently, and they've taken the prominent stars they have in the sky, and they've created their important part of their culture in the stars. So it's fun to think about the other cultures and how they see the sky. All right, so 2 last things I want to talk about. How's our time? We're good.
We still got time.
Yeah. If you want to take a trip and see the southern sky, you can do what a number of rascals have done, and that's go to Oz Sky. So there's an event that's put on by volunteers in Australia, and I'll just bring up the link for you to see it. Open hyperlink here. Oops. I'll use Chrome, yes, please. Okay. So that's the t-shirt I'm wearing today. So what they do is they take a week in the Canadian spring or their autumn, when the best eye candy is high in the sky, the Milky Way is high in the sky. So it's a fantastic time for imaging. And they reserve a motel out in the middle of nowhere in the about a few hours north of Sydney. It's near the Siding Spring Observatory. And for about a week, you stay in this location where all the lights are off. They keep it completely dark sky. They supply you with the telescopes. So when I was there, we had 12-inch, 16-inch, 24-inch telescopes, Dobsonian telescopes. They had a number of them. They had 12-inch telescopes made into binoculars. So you would sit and look in the 2 eyepieces, one with each eye, and the 2 telescopes would be behind your head. So you'd face the wrong way, but it was literally like piloting a starship.
That's insane.
You use 12-inch binoculars, 12-inch Dobsonians as each element of a binocular pair.
God.
And the volunteers help you with everything. They even, if it's cloudy at bedtime, they'll wake you up at 2 o'clock if the skies clear up. During the daytime, they have hikes into the bush, visit the observatory, Siding Spring, and it's an amazing event. And it's very reasonably priced. basically you share accommodations, you buy and cook your own food, or you can go into town. Town's not a big town, but you can do it. So I can't praise them enough. Oskai, once travel is back up and running, it's an amazing. They have talks during the afternoon of experts on different southern skies and different things and the nature of Australia. So Oskai, put it on your bucket list. It's something that's amazing to do.
That's like the glamping of astronomy, having somebody wake you up when it's clear out and everything. Oh,
Yeah. And uncovering the telescopes and putting them away for
Oh.
you when it's ready for bed. And yeah,
oh,
they supply the eyepieces and everything. Yeah, it's amazing.
oh man.
So that's Oskai. And the last thing I just thought I'd leave us on is what would bring Australian or Southern Hemisphere astronomers to Canada to see Canadian skies? Because we can go there and see things that we've never seen, but obviously there are things that we have that they've never seen. So what do you think, Jenna?
That's a very good question.
If you grew up in the Southern Hemisphere, it's going to crash. It's okay. I'll restart it.
I guess they can see Andromeda just fine, eh? At certain times of the year.
I think they can get it. Yeah, I could think of
Shoot.
two main things to come to
What are you
Canada.
thinking of?
Yeah. Anybody answered in the chat?
No, although Maria has suggested that we need something like Oskai here, Ursa Major and Ursa Minor from Phil. Anybody on YouTube?
Yeah. Well, Phil's got it. The Big Dipper.
Yeah.
The Big Dipper is so famous, right?
Yeah.
They don't see the Big Dipper. So everybody wants to see the Big Dipper when they come to Canada or they come to the northern hemisphere.
That's fair. That's fair.
So I think that's fair. And the other one, to my thinking, it's got to be Polaris.
Yeah, they'd be jealous of our pole star.
Got to be Polaris. Let's see, what else is circumpolar? I think that those are the ones I thought of. I mean, if somebody has any ideas.
The Southern Hemisphere has so many amazing things, from like the large and small Magellanic clouds and like all that. There's so much cool stuff going on there. Yes, a couple people have recommended, and I like this one, the Tim Horton constellation, which has, of course, the double and the donut in it.
Yeah, depending on where you live, it could be hidden at the horizon or just a peak. You could just peek. The Ring Nebula might just peek out for somebody, depending on how far south they were. But yeah,
doesn't count unless you're in the land of coffee and donuts.
Yeah, but they've got the better globular clusters. The Pleiades just as good as we do. They've got like star-forming nebulas like nobody's business. So
yeah, they've got a lot of good stuff down there.
It's worth going down there for. And if you do that, try to plan to do some kind of astronomy. Even if you go to to Uluru or a place like that, they have astronomy events that they run there. Mike Watson has given a talk. I think his talk is probably on the Rask YouTube channel, and he talks about setting up telescopes and imaging near Uluru and getting the skies down there. So yeah. So that's kind of the material I had prepared. I'm happy to answer questions or show other stuff or whatever anybody wants to talk about.
Thank you for the massive tour. So far, you've answered questions as they've come up. If anybody has any extra questions, please do throw them in there. There's Galen's throwing in jokes, saying that we could rename Cassiopeia to Wallaby to entice them up here. So a couple questions more about the aligning the telescope. How do you polar align a telescope in the southern hemisphere? Do you know?
Well, in a German equatorial mount polar scope, which is the scope that runs through the mount, generally you've got the stars plotted, etched into the view, and then you move your mount to put Polaris in the right spot with respect to those etched stars. And in the southern hemisphere, they etch the stars of octans, and so you can put them in the right spot, and you can you can get your mount aligned that way.
But I guess almost impossible at the equator, where you can't see either, eh? Just try to get it as level as
so you have to use there are other tricks like drift aligning and different things like that. Let me show you. Yeah, that's a good point. So I think, yeah, I mean, we generally use Polaris, it's within, so we've got, that's a pretty dim star. That's magnitude 9.65. I think in the southern hemisphere, they have stars that are brighter than that, about that far away, so they can, use a little triangle. I remember using the little triangle that I showed. Let's
Okay.
see if I can show you that. Let's see. Hands. I'm going to hide the sky. So, yeah, so here's the celestial equator. I remember seeing this little triangle, 1, 2, 3.
Okay.
That's help. And those are pretty bright. So this one is magnitude 6.8. So these are easy binocular target, and certainly
Yeah.
naked eye in a dark sky. So you've got some candidates to help you.
Okay. And then there's a question which I'm pretty sure I can answer with one of Michael Watson's photos about seeing zodiacal light in Australia. And I'm pretty sure you got a photo of zodiacal light in Australia. Um, we'll see if I can find that. Do you know, Chris, if you can see the zodiacal light in Australia?
So the trick to a zodiacal light is to get the ecliptic rising from the horizon as vertically as you can. And that way, the dust in the plane of the solar system remains in view after the sun is well below the horizon. So they're at mid-southern latitudes, just like we're at mid-northern latitudes. So it's different times of the year, but they have the same possibility. On the equator, though, the ecliptic's always vertical. We're close, quite close to vertical. So you have a better window for seeing it near the equator.
And that, I suppose that would be more around the equinoxes, because that would be when the equator is directly over. Nope, not the equinoxes. Yeah, the equinoxes.
No, you're
Yeah.
right. But it's, let me just find it. Night sky month. I'll tell you when the next zodiacal light is. So
It's going to be in October. I know that.
mid-September. So starting around mid-September, we can see the zodiacal light in the morning.
For those who do not know what zodiacal light it is the light reflected off of the dust in the plane of the solar system. So in the same line as all the planets and the star, sorry, not the stars, all the planets are on. There's leftover dust there, and you can see the light reflecting back from it. Thank you, Michael, for jumping in with the photo that I had thought of that you got in Australia of the zodiacal light.
Yeah, I can show it. Let me just show you. So let's go to 5 in the morning. So, and I need to bring that back. Okay. So the morning ecliptic is quite vertical compared to the horizon. And in Stellarium, what you can do is go here, go to sky, click on zodiacal light brightness, and you can crank the number up.
Ooh.
And you can make it noticeable. Let's see if that's enough. And you've got to pick a time when so the moon's there. So let me just get rid of the moon. And let's see. I've done this in Stellarium before. You can sort of see there's a brightness around here, but that's basically how you do it.
Cool. So that is, I've never seen it before, but it is a relatively bright thing to look at in the sky. It's just, it looks like light pollution. So I think a lot of people get confused.
You need to be away from light pollution to see it.
Yeah. And even when you are, it kind of has, very subtle. So that'd be cool. Neat one to see in Australia. I think that covers all the questions we have for now. I wouldn't mind throwing out a couple of things about what's going on in the upcoming days and hours. Is that okay, Chris?
Yeah. So of course we have tonight.
Yeah, tonight is the peak of the Perseids meteor shower, which we've talked about. I think we talked about on the last episode, because that was around the start of the meteor shower. And tonight and tomorrow night are going to be the nights with the most meteors on them as we pass through the densest part of the cloud. And so we're trying something new tonight. We have, and I mentioned this before, I believe, we have a Discord server. Discord's normally used for talking while video gaming. So you can type to each other and you can listen to each other. We're going to jump on tonight. I'm going to be there at 9 p.m. Eastern time until about midnight Eastern time, out observing down by the lake. And so we'll be there to answer questions with a couple of other hosts jumping in from across the country as well to help answer questions. And we'll share our observations there. So if you would like to join, I just sent out the Discord link in our chat, so you can just join our Discord, and then we'll be on the voice channel, the Observing Voice channel on there from 9 p.m. to midnight Eastern time. And so that we're hoping will be a way to share our observations in a time when we can't necessarily be near people. So that should be fun. So that'll be tonight. Feel free to join us. And then in terms of other stuff coming up, oh, one of the other things that's happening is that we're hitting our limit for our Insider's Guide to the Galaxy shows again, the one that we set ourselves, which is going to be our next session. Our next session is our last planned session, and we wanted to talk to you guys about when works best for you if moving forward into the fall. We are a little bit restricted on whether or not we can have this in after work hours, because Chris is a volunteer. Thank you for all the time that you volunteer, Chris. I am not. So I run into not, hitting my time on work. So we can maybe push it back a little bit if there are kids who are joining who are coming in from after school, anything like that. Send us messages, and then next week I will also host a poll. So probably the best way to do it. Do you want to do it now? Yeah, we'll do it next week.
Sure.
As we start up, and then we'll make that decision in the next couple of days after next week's session, or sorry, 2 weeks from now session, to see what our timing is going to be like. So think about it. Think about what makes most sense.
Let us know what people would like. We certainly want to satisfy as many people as we can. We'll make it a win-win. So I have one more event that I want people to be on the heads up about.
Yes.
And that is Jupiter. So on Friday night, before midnight and then into the after midnight, I'm going to show you Jupiter so you can see what you'll be able to see. So this is Friday night, August 14th. And you don't need a giant telescope, but a decent one will be good. So you can see that this black dot is the shadow of the moon Ganymede being cast on Jupiter's face by the sun. So it's basically a little eclipse. Ganymede is creating a solar eclipse on Jupiter. And as Ganymede orbits the planet, the shadow will move across Jupiter. And at the same time, Jupiter is rotating once every 10 hours. So the great red spot will be underneath it. And as time goes by, so we're heading, this is 11 p.m. local time in Toronto, or Eastern time. So it's 11 Eastern time. You'll have to adjust for your time zone to decide whether Jupiter is in the dark sky enough yet. But as we go, the shadow is crossing or transiting Jupiter's face with the red spot. And then as we get towards midnight, something really rare happens, and that's a second shadow appears. So now Io is casting its shadow. And by the way, Ganymede is a bigger moon, so its shadow is a larger diameter than Io's. Also, Ganymede is farther from Jupiter, so it makes a bigger shadow than Io, which is tucked in closer. So if you can stay up till after midnight and you've got a decent telescope, you can see 1, 2, 3, 2 shadows and the red spot. And if you have a really good telescope, you need a big one, like good quality optics and good seeing. You can even pick out Io itself. But the moons are sort of camouflaged compared to Jupiter, so they're harder to pick out. But that's a calendar, put it on your calendar thing for Friday night.
That's a very cool target.
Yeah. I think that was, oh, and then on Saturday, just to wrap up, let's wind back out here a little bit. So we have Mars. Mars comes up, keep your eye on Mars. Mars is getting better and better. Mars is rising at late evening, about 10 p.m. now, and it's red. But then in the morning, we have Venus. So on Saturday morning, we've got the crescent moon hanging out with Venus in the morning sky, pre-morning sky. By the way, all this brightness, that's the zodiacal light. We just turn that back down. That shouldn't be there. All right. Yeah. Let's wind this back down to something reasonable. There we go. Okay. Yeah. So you have the moon and Venus. But what's cool is that you can see Venus in the daytime. So once the sun comes up, being careful not to point your binoculars near the sun, okay, please, everybody. Parental supervision is a must here. But you can see that the moon, I'm just going to make the moon the right size because I got a double solar system, take off the moon scaling. So that's the true size of the moon. So it's about, I don't know, 8 moon diameters to the lower right. As you
I
can
think that's
pick
pretty
up.
close.
Yeah, if you use binoculars, you should be able to pick up Venus in the daytime. It's bright enough to see it. Let's see if I can.
Daytime astronomy is my kind of astronomy.
There we go. So that's about the field of view of binoculars.
Oh, cool.
And you've got until all day. I don't think Venus sets until 6 p.m. So by around 10:30, Venus is below the moon. And then in the afternoon, it's sort of to the lower left. And then we're getting down again.
Cool.
So those are my tips for the week.
Very cool. Thank you very much, Chris. And we've had a couple questions about some maybe new topics, including possibly talking about the zodiac signs and how they got their names and what they are and that sort of stuff. We just asked, I had a question from Graham White asking about affordable good telescopes, and we did have an introductory telescope session already, so that is up on YouTube if you want to check it out. Along or all past sessions as well, they're all on YouTube, so if you need to go back and look at any of those, they're up there. And our next session is going to be about, oh no, have I already forgotten? I've already forgotten. The next session is about summer and fall planet viewing. So we're going to be talking specifically about the planets that we can see in the fall as we're coming up to the opposition of Mars, which is going to be very exciting.
Yeah.
So that's it for this week. Thank you everybody for joining us. Chris, do you have anything else you want to add before I wrap up?
I think that's it. So if you're going to look for Perseids, you can go out in the evening because the moon will rise about 12:30 and the moon will start spoiling the show a little bit. I know most media are telling you to get out before dawn, but the moon will be sitting right there by the radiance.
Yeah.
So
Not
just
this
find
time.
yourself a spot with as much open sky as you can get and as few lights as you can get, and just lay back and watch. Don't look at your phone.
Yeah.
Right?
And that
Just
actually
look
is
up.
a point that I'll add about the Discord. The Discord voice chat is on a gray and black screen, which is pretty good for nighttime. But even still, once you're on, maybe bring headphones or something and then just turn off your screen and don't look at it. Because that's the whole point of the voice chat over a video, is that we don't want to be ruining our night vision.
Exactly.
Alrighty.
And, good luck, everybody.
Thanks everyone for joining. Hope to see you or hear you guys tonight. We'll see you again for Explore the Universe next week, and then Insider's Guide to the Galaxy the week after. And have a lovely time observing. Enjoy space. Thank you, Chris, for telling us all about what's happening in the South.
My pleasure. And keep looking up.
Keep looking up. Have a good day, guys.
Bye.